access it on the WebAge website under the webinars area. Should be up within a couple of days as far as having access to the video recording, and you'll also be able to, as usual, download a PDF of the slides that we'll be showing today. So you'll have that for your future reference. Also, at the end of the presentation, I'll be pasting some text with some links in it into the chat panel so that you'll all be able to grab that and just copy it as one block and paste it into a document, and that will have links for some reference material, some related courses that we offer, as well as our contact information. So I'll do that at the end and make sure that everybody that joins gets that. If I paste it too soon, people that join later will not see it, so I'll just wait till the end of the webinar. I assume most of you are familiar with the GoToWebinar layout, but just wanted to point out a few things that are important to your user experience. It's very easy to collapse and expand the panel. You see at the top here a little button that will get rid of the panel. The main viewing panel that you see that shows the actual slide content, you can resize that around your screen, drag it, and it will resize accordingly. If you would like to adjust the zoom level different than the default, just use that drop-down zoom dialog at the top of the viewer panel, and you'll be able to zoom in at any time or resize as you like. If you leave it set to automatic, you'll just be able to get you'll get the size of whatever you resize the panel to. I'd like to encourage everyone to use the question feature. Just type in your question as we go along. If you have any, I'll try to address them as they come up, but we'll certainly make time at the end to address anything that I wasn't able to get to. So I'd encourage any questions or comments that you might have along the way. Okay, we'll go ahead and move forward. Our topic today is reference architecture. Very important topic, very fundamental to the success of most architecture projects. And I think you'll see as we go along, I'm sure you've all experienced the use of reference architectures in one form or another. And the form that they take varies dramatically depending on the type of domain that you're addressing and the type of organization that you're in, whether it's large or small, and the degree of formality that's required to communicate reference architecture. We'll talk about that. Just as a brief introduction here, again, my name is Doug Rinker. I'm an instructor and custom content developer for WebAge. Most of the courses I teach are in the arena of enterprise architecture, solution architecture, and particularly the TOGAF framework, which is one of our leading frameworks that the world is using these days at the enterprise architecture level for defining broad cross-discipline, cross-organization architectural definitions. I mentioned Christine Thompson because she's been instrumental in putting material together for not only this presentation, but other presentations in the WebAge architecture series. And for those of you that are new to the webinar series, just a reminder that WebAge is does offer a very complete set of architectural courses at all levels. Short format with 1 or 2 day introductory style classes, all the way up to 4-day practitioner level classes. And we cover the worlds of enterprise architecture. And along with that, there are separate courses that focus specifically on the TOGAF framework and preparing people for certification in TOGAF if they're interested, which also can be a fundamentals 2-day course or a full 4-day course. And then lower level architectural courses, also 4 days or shorter in length for solution architecture and software architecture, specializing in different areas such as SOA and cloud and big data and those types of topics. So you can just go to webagesolutions.com and find additional information on the courses that are available. So just a quick overview of what we're going to be looking at today. We'll take a look at just the standard definitions, the most common definitions of reference architecture, why we have them, the basic purpose. We'll look at some examples of at least the visual diagrams that are associated with some fairly popular and common styles of representing reference architecture to give you an idea that they can take many forms and cover, be very broad or very narrow depending on the domain and the level of architecture that you're working at. And we'll take a look at the fundamental elements that make up a reference architecture. A lot of people associate reference architecture with just models, but we'll see that they're actually, they include models, but a complete reference architecture definition has a lot more information in it than just the models themselves. And then we'll get into the recommendations area, which is really just an extension, some suggestions about how to think about reference architecture and aspects that will help you get maximum use from the reference architecture work that you do. And then just a recap of our course offerings that elaborate on architectural aspects that include reference architecture. So if we just look at some common definitions out there, and like a lot of topics in the architecture world or in the IT world in general, or in the business world in general, there are concise definitions, and you often find that to have a complete grasp of a concept, you really have to look at multiple definitions because no one single concise definition captures the entire concept adequately. They just hit certain points. So this is a good cross-section of some commonly used definitions. You'll see the characteristics. First one talks about reference architecture providing a template type of solution. Templates, you see the word template shows up in two places. It's also used down here, which indicates that we're looking for something that's a little bit abstract, a little bit generic, but useful in giving us a starting point and adequate guidance for a particular type of solution that we're looking for, which is really why we use reference material in general in any type of design or engineering work. In the middle definition, you see a reference to models and building blocks, and that's a very important aspect. But again, I'd mentioned that a complete reference architecture entails a lot more than just the models, but the models and the definition and the behind-the-scenes documentation that describes the entities and the components and the building blocks that make up those reference architectures is very, very important. Then finally, we see a definition which focuses on, again, the template concept, but talks about the ability to reuse in the interest of giving people a head start in the right direction. This not only expedites, as it says here, but also allows us to get people going down a path that more rapidly aligns them with the goals that we have for our broader architectural interest in the organization. So it's not only a jumpstart capability, but it's an alignment capability to make sure solutions that are developed are going to integrate properly and the right types of standards are being used. It's a way of imposing a well thought out set of guidance and at the same time constraints on new development work so that we get the results that we're looking for as an organization. So if we think about the basic purpose of what we're trying to do when we lay out a reference architecture for people to use in their design and development work, we're trying to focus on the key decisions. We're trying to stay out of the weeds and not get down into too much detail, but we're focusing on what we consider to be the architecturally significant considerations, which oftentimes have to do with following standards that will allow us to integrate systems together effectively. We can have our models and our information and our entities arranged in a taxonomy that might just stay at the conceptual level. It might be all the way down at the physical implementation detail level, or kind of in the middle as what we think of as a logical view that expresses the main components, but in a way that doesn't get caught up in technology or implementation detail. All these different types of views, whether it's conceptual, logical, or physical, can be appropriate, but you have to pick and choose wisely the views that convey the level of the problem space that you're at. Some things you would tend to only deal with physical representations if you were dealing with the low-level details of infrastructure and implementation. So many of the examples we'll look at are completely devoid of any physical views, because that's not the level that we're communicating at. A lot of times when we're dealing with architecture, by definition, we're trying to emphasize things that are higher level concern, broader concern, in a more abstract way. And oftentimes, again, unless we're targeting an infrastructure platform strategy as part of our architecture work, we tend to keep our discussions up above the level of technology and technology detail. Very important aspect of any architecture project, whether it's solution architecture or higher, broader enterprise architecture, is that you get the sponsors, the stakeholders, the management, the development team itself to have a very clear shared vision of what they're going to, the overall approach they're going to take to reach a solution. And it's sort of like a solution hypothesis definition. And reference architectures, if they're put forward up front as they should be as a suggested set of guidance, can be a tremendous value to creating a higher quality vision, because it creates it answers a lot of questions and eliminates a lot of variables, and just tends to get everybody focused on the direction that we're going to take. And because reference architecture is one of the many things they do for us, is to help us to systematically go through a series of concepts, forces us to think about it, forces us to answer questions for ourselves about which things will and won't apply. And by doing that, we can often uncover issues and risks that we might have to deal with, and help us make key decisions much earlier in the cycle, which is a good thing. And oftentimes those can be in areas that we would otherwise maybe neglect or not think about adequately until too late in the project. So we talk about scope and context. The range of subject matter area that reference architectures cover can vary dramatically. And again, it all depends, are we working at the enterprise architecture level, where we're looking at broad, high-level architectural considerations, the ideas of integrating multiple disparate systems across multiple business units perhaps, or are we down at a more detailed solution or in a specific problem domain, or are we working within one of the domains of enterprise and solution architecture, such as the business architecture domain, or the application domain, or the data domain? So we can have reference architectures that are focused on each one of those different levels or each one of those domains. And many reference architectures are put forward in a layered approach that actually spans multiple domains. And we'll see some examples of that. Ideally, you should have reference architecture available for all levels that you're going to be working at. But of course, you don't always have the luxury of having a fully developed reference architecture at every level or in every domain. So it's really important to at least have, or make an attempt to have a high quality reference architecture established for the level that is most strategically important for the type of project that you're working on. Oftentimes that is at the highest level, and it's not so essential when you get down into the lower levels of design and solutions, because those areas might already have adequate reference material in place, but you may be lacking it at the higher level, where you're concerned about getting siloed legacy systems that aren't used to talking to each other, for example, to be better integrated and have common shared canonical data definitions, for example. And one thing I want to mention here too is that what I've seen from many organizations is that when we talk about context, it's not always just the case that you're looking to have reference architecture to give you guidance on how to create a specific solution. Sometimes, for example, the enterprise architecture discipline within a large organization, their main activity might be to define a roadmap of, here's the technology infrastructure we're trying to put in place at all the different levels of the stack, and all the way from technology, a low-level information service technology stack, up to the middleware level, up to the business application level, up to the user presentation level. And they may have established a set of preferred technologies that they're trying to standardize on across the entire organization at all those different levels. So they might put together a reference architecture that describes generically what all those levels are intending to do for all future projects, for all future solutions, or at least the vast majority of them. So that reference architecture becomes useful then for all upcoming business solution projects to use as a reference, because the expectation is that as you deploy new business solutions, we want you to design in the hooks and use the standards and use the interfaces and use the types of technologies that will allow you to integrate in with this broader enterprise-wide set of architectural technologies and standards that we've agreed on. So sometimes it's a backdrop of surrounding architecture that's already been established and defined as a future goal, and by using that it allow you to steer your project work so that all new deployments will fit into that as easily as possible. And by defining the reference architecture in those terms, gives everybody the guidance and the insight that they need to make that happen in the at least painful way. So here's an example. Let me just zoom a little bit. This is an example of an organization saying, you know, for our new enterprise level architecture, over the last few years, we've been transitioning into a new set of concerns because of the influence of the cloud, the influence of big data, the influence of mobile concerns. And so we're looking at a focus here that's very high level, focusing on the things that are addressing the fact that we have many disparate and new types of data to work with. We have a need to virtualize that data. So if we look at the bottom and start from the bottom up, we see that we've got 3 different categories of data. Traditional structured data that we've been always using since the beginning of time. We're using the concept of relational databases. To the other end of the spectrum, where we've got very, very high volumes of data that don't lend themselves to structured relational treatment. So that would be in the category of big data, where we might use technologies like NoSQL. And then we have a wide variety of just generally unstructured data, such as media, engineering drawings, wide variety of different types of documents, where we need to be able to address you know, the ability to have automatic analysis of that material, to attach tags and categorize things using a context-aware technology, analysis technology. We need to bring all that, because we have all these new disparate sources of data that all are required in various ways as we look across our set of business applications. We need a way of virtualizing that so that we can pull that information together in a common shared model of information that we can hold steady and hold constant, while all the lower level actual sources of data come and go and undergo change at the physical level. We need new ways of searching that will tie into our context-aware capabilities so that we can search this unstructured data more effectively than we've been able to do in the past. So the bottom few layers here are all dealing with information and data and bringing that together in a common shared format that our applications can draw upon in the future. And then we get into the application layer itself, where we've got our legacy packaged applications such as ERP systems, our legacy customized applications, and then more recently, maybe we've been moving into the cloud for certain applications that lend themselves to the cloud. So, software as a service, possibly for our customer relations management, or any number of different types of business applications that are available out there. So we probably have a mix of things that we need to keep in-house for technology or security reasons, other areas that we need the scalability and flexibility and cost effectiveness of being able to get the solution from the cloud. So we need the ability to do intelligent integration, to be able to automatically decide when we cross the line between our internal operations and our cloud operations, and coordinate that interaction and communication between those applications. Then we finally move up to the platform layer, where again we have some things that might lend themselves to what's being offered these days as platform as a service through the cloud. But then all the other types of platforms that we might have had, the traditional platforms we might have had for development and deployment of in-house applications that we've developed for ourselves. But probably in more recent years, we've had to put additional focus on mobile enterprise applications, where we've had to deal with designing and deploying applications that are unique to the native characteristics of various types of mobile devices, for example. And then the mashup concept of being able to bring together, we have all these different disparate sources of information that come from the lower levels. How do we efficiently design a presentation layer to make that stuff visually available to our users through the applications? So might need more specialization and more capability in that area through a platform concept. And then finally, our user access. How does the world get to our business capabilities? In the past, maybe we had basic web capabilities. Now we're getting into more sophisticated mobile channels, more sophisticated specialized portals, and et cetera. So this is an example behind each one of these entities, as is true for all the reference architectures. This is an example of keeping things at a very high level and knowing that in addition to this very simple diagram, behind the scenes there is a detailed description of each of these blocks, discussing what types of things we are putting in place or have in place, what types of technologies we're using, what types of standards and policies are we enforcing. So this can give an organization the opportunity to stop and think. Maybe an organization has the goal to address most of these issues. So they find this reference architecture and the documentation that goes with it, describing each of these blocks. They find it by doing a search through the internet, and they bring it on board. And by using that as a generic starting point, they can go through block by block and ask themselves, which of these apply to us? Which of these guidance areas are we going to adopt? Gives them an excellent starting point. And they can tailor it and modify it to create their own version of this that's more suited to their internal characteristics. But the basic idea is to get at the enterprise architecture level, in this case, people focused on the primary areas of architectural influence that are going to support our future business needs. And obviously, there's a lot of lower level infrastructure detail that isn't even mentioned on this diagram, and that's intentional because we're focusing on these strategic aspects. So our next example is going from the enterprise level. So imagine that you're focusing on one or both of the cloud options here. Possibly, we do need one or more platform as a service solutions from the cloud, from a cloud provider, or perhaps just one or more software solutions. And we're looking for something a little deeper that it's a little more solution architecture oriented that will allow us to work through that. So here's an example that's more focused on the relationship between our organization as a cloud consumer and the cloud provider. And you notice the way this reference model is constructed. And again, just like the prior one, we see that there's a lot of simple entities represented here. The idea of this visual, like with all reference architectures, it's nice to have a set of diagrams, at least one, that give a high-level visual, at a glance orientation as to the types of architectural elements we're talking about, knowing that behind the scenes there's documentation that explains the details of what's behind each of these blocks and how they relate to each other and the types of services and standards and policies that go with those things, all aimed at giving you guidance or at least begging the question that you should answer for your organization as to which of those things you need and which of those things you don't need for the sake of complete analysis. So in this particular approach, you notice that there's 5 different major actors called out: the cloud consumer, cloud provider, the cloud broker, which is an optional entity if you decide that you need services from multiple cloud providers and managing that interrelationship is too complex, you might elect to use a cloud broker to manage and act as an intermediary to aggregate those services, or to provide an arbitrage function if you're trying to select the best service for any given piece of data or any given situation where the provider that you go to might vary depending on some business rules and that sort of thing. Then we have the cloud auditor, which is oftentimes useful for people to gain the confidence not only within their own internal organization but with their client base, and maybe there's regulatory issues they have to comply with. And then the cloud carrier, which may or may not be, is really providing the telecommunications linkage between you, the consumer, and the remote cloud provider services. And sometimes that capability might be integrated within the provider if they've linked up with through merger or whatever with a such as like Verizon as a telecommunication company being linked with Telemark. It's more like one-stop shopping. In other cases, the cloud carrier might be a separate agreement, but those are the people that you would have the SLAs as far as telecommunication quality and service level expectations. So it takes you down to the levels of addressing standard definitions for each of the types of service categories: software as a service, platform as a service, infrastructure as a service. Gets you to think about which of these do we need and why, what level of service is most appropriate for our needs, how do they handle the underlying hypervisor and virtual machine management activities. As you go lower down their stack, you probably, in a typical case, you care less about the details, but you might be very concerned about, from a management policy point of view and a service level point of view, how these things are managed. And a lot of that is addressed in the cloud service management area. So in each of these areas, you would find detailed descriptions with the associated documentation that describe what exactly types of services they provide in each of these categories. So again, this is more same ideas we saw in the first diagram, except we're more down to the specific domain, the cloud domain. Still looking at the subject of the cloud in a very generic way, but forcing us to think about all the different aspects that we need to work with. And once we down select to the areas that we need for our solution, we can recreate this reference model, take it from its generic form to something that's a little more organizational specific, still generic in the sense that we can use it for a wide range of solutions internally, but not so generic as what this represents that it seems like it's something that the whole world could use, something that's tailored a little bit more specifically for our organizational needs. And our third example is going down to a specific domain. So if we look at the last chart, or if we go back to the enterprise level chart, we had this concept here that was important at an enterprise level that we called data virtualization, which many of you have probably had some exposure to. You might be working with data virtualization in your current organization. But the basic idea is that we have a lot of different database systems, information, redundant information in some cases, coming from different sources, different formats. We need to bring it together in an organized fashion so that there's a single source with single understanding of what information means, like is commonly referred to as a canonical model or a shared information model that everybody across the enterprise can agree to at both the application and the business level. And we might say, well, it's not, we got the concept. We're trying to make this shared information model available to our applications so that we're abstracting away all the low-level differences of all these different disparate database systems to make it easier and quicker to design high-quality applications in the future that are based on a shared information definition. But how exactly do we go about doing that? So our third example is saying, well, let's dive down into the data domain and look at the data concerns specifically. Here it's called, this is from a Cisco model, it's called the data abstraction. But this is really showing a high-level reference representation of how Cisco's product provides data virtualization. So they're illustrating, I've got my raw data, my physical databases. I use some metadata to do the first cut at grouping information together, still maintaining a lot of the physical data description characteristics. So we're at the physical layer. Then I import that and reorganize it into my virtualized representation that uses our shared enterprise-wide canonical model of how we're going to represent shared information in a way that is agreeable and much easier to use from application to application. Also makes it much easier for us to integrate applications across our various business areas because they all have agreed on a common shared definition of information, despite all these physical differences that are kind of being hidden away with this approach. And then up at the application layer, the solution has the capability of taking that shared canonical model that we're using across the business and converting that information into the format and delivery using whatever messaging protocol or messaging standard is appropriate to convey that information to the various applications that need it. And all this is done in a very flexible, reconfigurable way. And it's considered by a lot of organizations as a superior way to approach things just because it can allow you to be much more agile, respond, because you don't have a static situation down here with your physical world, right? It's always changing, so you need a very quick, efficient, rapid way to adapt those changes while you maintain your canonical information model for the enterprise. And that's exactly what this type of architecture is designed to do for you. So once again, there's a lot of a reference architecture aimed at this particular subject of data virtualization. This is just the very simple high-level representation to get the basic idea across for people to have a shared understanding of what we're trying to accomplish at a glance, so to speak. And behind the scenes, there's documentation that describes exactly what the philosophy is in each of these layers, what types of parameters, what types of information, how do you design to take maximum advantage of the capabilities of this data virtualization scheme. So just these three examples to give you an idea that we can have reference architecture that's useful at a very high, broad enterprise level all the way down to specific domains and specific concepts. So if we take a closer look, so what we're really going to do here is explore what's considered to be, you know, a best practice definition of what good reference architecture should contain. So far, we've just been looking at simple visuals because those are the easiest way at a glance to get an idea of what reference architectures are trying to do for you. But this diagram, and this might be, let me just zoom this a little bit for you, and we'll move around the chart here. But just saw a question about how do I get a copy of the slides from this webinar. Like I mentioned right up front, the slides will be available if you go on the webagesolutions.com website and look under their webinars page. There's a major link for that right up toward the top of the homepage. You'll go to an area where it'll say view previous webinars, and when you go in there, you can select this one by its title and date, and it will allow you to download not only the video of the presentation that we're doing here right now, but also a PDF for the actual slides. So you'll be able to get everything that way. So what we're doing here is looking at, it's a meta model of a reference architecture. So it's kind of a model of how to construct a good reference architecture. Now, in an ideal world, you would have all these things. In a less than ideal world, you might have a lot of reference architectures that only have partial or maybe some of these areas not represented at all. The idea here is to give you, if you're thinking about developing a reference architecture that has a lot of strategic significance for your organization that a lot of people are going to look at, and it's going to be a key factor in getting the results you want from upcoming projects, you can use this diagram. Arguably, this might be the most important slide in this presentation because it gives you a complete definition of the types of things you should have in a reference architecture. And in the subsequent slides, we'll talk about these things in a little more detail. But fundamentally, you've got in the upper right with the orange color, you have principles, policies, and scenarios. These are things that sort of establish the broad context or the motivation of not only why is this reference architecture being used, why do we have this reference architecture, what are we trying to accomplish, but the high level elements that also put the teeth in how we're going to enforce it and put it in place. So it's one thing to have low level detailed technical standards and detailed models, but we also need the high level verbiage and documents to describe what are the big rules that we're following that are associated with this architecture, what are the key policies, both business-wise and IT and architecture-wise, and what are the business scenarios, kind of like an elaboration on the business use case concept where we describe, particularly in areas that are very, very important that may not be well understood, we go out of our way to describe here's the exact process situation that and the actors that are involved and the processes and technologies that are involved that we're trying to assist or enable or improve with this reference architecture. So these are considered to be the foundational elements. Then we come to some other supporting things that really aren't graphical in nature, more like documentation oriented. We have the glossary, very important concept because that helps us with the language to make sure that everybody's on the same page as far as terminology. I'm sure you've all run into situations where there wasn't an adequate understood upfront definition of what certain terms meant. You had different groups, different people walking around with different ideas of how to interpret what does service orientation really mean in our organization? And you can get 10 people and give you 10 completely different answers. The glossary is here is saying with respect to what we're trying to tackle in this particular reference architecture, here's the key concepts and the key terms and explicit definitions to make it as clear as possible to everyone involved exactly what we mean and don't mean by these various concepts and terms. Under the category of practices, it really comes down to some are formalized and have strict compliance requirements associated with them. We'd consider those to be our standards, and standards can be business architecture level standards, they can be data standards, application standards, technology, infrastructure standards, standards for any type of domain. And a lot of times our standards, sometimes they just come from industry because we're trying to be industry compliant and with our open architectures. But other times we might have more homegrown standards that have grown out of what used to be just considered best practice. And we thought, we've seen this work so successfully enough times that we're going to take it out of the best practice category and put it into the standards category to sort of institutionalize it, to make it a requirement to use this particular best practice. And for things that haven't risen to that level but are still very important that we want people to understand as far as guidance and things that we've found to work very well in the past, we go ahead and document those things in our best practice category. Because after all, a lot of what we're trying to do in many cases when we use reference architecture is to take what the enabling concepts that have been very, very useful to us in the past that we've got a good track record with, and through the use of a reference architecture, try to institutionalize those things by building all that guidance information into the reference architecture itself. Keeps us from reinventing the wheel. It allows us to always have our best foot forward on a new project because we can feel confident that the reference architecture is going to include everything we've learned that we would want to continue to do and build on from past projects, and or it may have come from maybe we don't have that much direct experience internally, but maybe that guidance and best practice came from external resources, consultants that we've used, or technology that's proven to be very effective in the industry in general, or at least people in our line of business, and we want to tap into that. So we've gotten a little bit of exposure to it through some prototyping, perhaps. We still want to. Reference architecture is not just about what's worked well for us in the past internally. There's a lot of that, but it also has to point us toward the future. So when we're pointing toward future things, by definition, sometimes we don't have a tremendous amount of internal experience with those concepts. So we need to rely on other techniques to give us the confidence level we need. But in either case, the idea is to convey the best possible guidance to get people off on the right foot. Then we come to our lower right section here, the category of reference models, which is what most people associate with reference architecture. They think automatically, oh, okay, it's just a model with some components and that's about it. But the main point of this slide is there's a lot more than that. But the reference model is very important because that's a lot of times the first vehicle that people will look at to get a basic understanding of what we're trying to do. It's the most commonly used vehicle for communication, so it's very important in that regard. So when we look at reference models, they're basically like any type of system definition that's showing us a set of components, which oftentimes we might refer to as building blocks. These might be high-level abstract logical components, or they might be low-level detailed physical components, depending on what level we are trying to describe with this particular reference architecture. A lot of times there are patterns. I'm sure most of you are familiar with the concept of patterns. They exist in software engineering, solution architecture, and even enterprise architecture makes use of patterns. Commonly we see things like the facade pattern to encourage information hiding and encapsulation. We'll see the idea of enterprise integration patterns, which have to do with best practice ways to set up components to carry out messaging activities, so we can separate the task of moving messages between applications from the application design itself, so that we can loosely couple those two concepts as you would typically want to have in a modern organization. Lots of different patterns out there. And in a lot of ways, patterns are highly parallel in their conceptual nature with reference architecture. The main thing that makes reference architecture different than patterns is the fact that reference architecture will take a pattern which is normally very, very generic, very, very abstract, not aimed at any one organization's needs, but a very broad general way of solving a particular kind of problem, usually by saying, if I have components for these activities and I distribute responsibility between these components in the following way, and I have these kind of relationships among these components, your architecture will be optimized for redundancy or failover or high availability or high usability, whatever the various soft goals or characteristics are, quality characteristics you might be looking for. Patterns are designed to provide solutions optimized around one or more of those types of qualities, and sometimes at the expense of other qualities. So there's always a trade-off. What reference architecture will tend to do oftentimes is take established patterns that have known goodness and sort of instantiate them to make them a little more real, a little more specific to an organization or to an industry, or some lower level, more specialized purpose. So that's where the reference model takes maybe generic industry patterns and transforms those into, or uses those as the basis for a more business specific reference architecture that will be useful to our future projects. And so we use that term partial instantiation, because you're not trying to take, the reference architecture by definition is still somewhat generic, still somewhat abstract. It's not trying to provide a specific solution, it's trying to provide guidance on how to create a wide range of solutions given a certain starting point, giving a certain set of surrounding assumptions. So within the components then, these can be at any level of detail or specificity. We can optionally break them down into features and lower level requirements. And we have to be careful here and remember that we're not trying to design a system. We're only trying to call out what we consider to be very, very architecturally significant capabilities, things that are important to us achieving our architectural goals. Same for requirements. Where you do have architecturally significant requirements, though, it's important to document them as part of the reference architecture, because requirements, when you think about it, are the one thing that can tie us in or anchor us with the actual solution development, the actual solution design, the actual models that are created for a specific solution. So from a traceability standpoint, if you want to show how your solution is made use of or has complied with a certain reference architecture, those requirements allow you to establish that traceability link. So the following slides I'm going to go through fairly quickly, because we've sort of talked about it's just some words to emphasize that I find it's more useful to discuss those ideas while we're looking at the diagram, because it sort of shows how everything fits together, as opposed to looking at a lot of words. As a question came in, should principles under reference architecture include all the domains, for example, business, data, application, and technology? The answer to that is it really just depends. The principles should match the scope of the reference architecture. So when we were looking at the example of a reference architecture for data visualization, example number 3 that was showing how Cisco does their data, the principles there would be about reinforcing the value of having a enterprise-wide canonical information model, for example, because those are very relevant to why we do data virtualization the way we do it. So yeah, you wouldn't necessarily want to throw in principles for all the domains unless your reference architecture was broad enough to encompass those domains. That would be the typical approach. So the very first example we looked at that was an enterprise-wide, the one that showed all the different types of application platforms, all the different types of sources of data across the enterprise, virtualization, application platforms, and so on. In that case, it would probably be appropriate to have principles that are at all the different levels of business, data, application, and technology, because to some degree they would apply. So you select principles to reinforce the specific values or key rules that are important to that particular problem that you're trying to solve with that particular reference architecture. So it's just a recap of those items we just looked at on that chart, things that we want to have in a good reference architecture. A little bit of detail about principles. We won't spend too much time on this, but you can think of principles as being the big rules, or the highest level management driven guidance. And it can be business management, it can be architectural. You can have business principles, and you can also have architectural principles that might restate those business principles in architectural terms. And as we just mentioned, we can go down the line and we can have principles that are focused on data, applications, and so on. But the common theme of principles is that these are intended to be overarching guidance that would be the ultimate decision maker if you're in an architecture review board meeting and you're trying to decide whether somebody's complied with the spirit of what the architecture is. It's going to ultimately rise to the level, are you adhering to our basic principles? It's going to be typically these would be enforced to make it very difficult to not follow your core principles that have been set up for a certain type of architecture. These are written to be above, the principles are written to transcend specific technologies, specific systems. They're typically not written specifically with any kind of technology or application or system detail. They are not requirements. They are not written with, typically with quantitative, measurable goals, and they're not written against specific systems again. So they're high level. So you can't design a system off of them, but they express the values. So when you're trying to make decisions and you're having trade-off analysis discussions about which way should we take this design, the whole idea of having principles is to help people make better decisions so that what they end up with is more closely aligned with the high-level principles that the organization wants to have. And it's important to have a balanced set, because we've all seen what happens if a manager comes out and says, this is our one principle. We must we must comply with this accessibility principle that above all else, nothing else matters. Or at least that's the implication. Well, everybody then games the system. They optimize for that one thing at the expense of too many other things. So you really need to have a balanced set of principles. You select your principles based on the challenges you know you're going to face, and sometimes even the culture of the organization. If you know that you're in an organization with a bunch of silos of people that aren't used to working together, and you're trying to introduce the idea of coordinated, integrated data sharing between systems that normally have not had to work together in the past, and you know it's going to be an uphill battle to convince these people that they should find a way to share their data, you might go out of your way to create some principles that address the value of data sharing, for example, or treating data as an asset. So you have to be very smart as a leadership and management team about how you pick your principles. They are very important in terms of conveying what's important to the organization at a very high level. And as technology changes and as applications come and go and as business processes change, these high-level principles will tend to remain the same for long periods of time. So they're really a statement of what do we value as far as our overall approaches going years into the future. Policies are, we talked about the advantage of those. They're sort of a document that can describe how do we fulfill principles. They might call out standards where the standards have lower level technical detail in them about how certain things are going to be accomplished. Policies can help us with both subjective and objective. It could be extremely objective, like how to establish password acceptability or quality, all the way up to, reuse, or the desire to maximize the component reuse across the organization, which has a lot of subjective aspects to it. And just like standards, policies are enforceable, and oftentimes they're worth creating because it allows us to create procedures that are backed by a policy. So there's kind of a lineage, and then when we have those procedures, we can hold formal compliance reviews to make sure that those procedures and policies are being adhered to. Scenarios, we talked about those. They have a lot in common with fully described use cases, but they're elaborated a little bit more than a typical use case, and we use scenarios selectively to describe how a certain process and how certain actors are going to interact with our process in areas that we are particularly concerned about, that maybe are exposing or describing the problem or describing the way we want it to work, maybe the as is versus the to be version of a business process in the real world, how it works now, how we want it to work in the future, to give people a much clearer visualization of what we're trying to achieve through this reference architecture. Here's the glossary, and we talked about most of these points. Just very important to have all of our terms and concepts, because it can be very damaging if we don't have people having a shared common understanding of what our key terms mean. They may look at the reference model and say, yeah, I understand these concepts, and then walk off and do something that was completely undesired because they didn't really understand what the concept or term was all about. So the glossary is our first line of defense of providing a consistent definition for everybody. And for people that are coming on board, we always have a wide variety of different stakeholders we're trying to work with. It's good to have a way for them to onboard new people to the team, to onboard stakeholders, anything that, to whatever extent a glossary can contribute to a higher quality understanding of the overall reference architecture. Standards, just much like policies, except lower level and more objective in their nature. Very, very good way to capture and institutionalize our best practices, and a very good way to enhance the way we do governance. Because if we have standards, it makes it easier for us to say, here are the standards that apply to you. We expect you to comply, and we're gonna do compliance reviews to make sure that you do comply. Guidelines and best practices, as I mentioned earlier, oftentimes if those are really, really good best practices, we might make standards out of them. But even if we don't, they're still very important to giving practical guidance. A lot of times the idea of showing a sample or an example as part of the reference architecture information to show how this reference architecture was used on a prior project to solve a particular problem, even though that's not the exact problem we're trying to solve. By expressing that as an example, it gives people that much better idea of how to use the reference architecture effectively for their upcoming project work. And we have the idea of building blocks, which really comes into play when we have within the reference model. So the reference model is where we show the visual idea. And the reason we have visual models that use building block symbols is to capture those basic ideas in a very easy to grasp way. Gives us a very high level bird's eye view at a glance. It's focused on the key concepts. There's a lot of things a simple diagram doesn't explain to you, obviously, and that's why once you understand the general nature of what the diagram is trying to show, what the model and the blocks are trying to show you, you go behind the scenes, and there would typically be good quality documentation explaining the specifics of what a building block represents, what it brings to the table, what standards it's following, what technology is being used, and so on. Whatever is appropriate for that level of abstraction. And it's important that by having the diagram is really your first step of creating a taxonomy. We're going to run a little bit long here today because we have about 30 slides, and I'm going to go quickly through the remainder. So we might run about 10 minutes long here. If anybody has to run, please keep in mind that you can download the recording and the slides within the next day or two by going to the website. A nice thing about managing complexity is that the building blocks that show up on the diagram are our first cut at breaking down the overall issue we're trying to solve into components that we can separately manage. So it takes the problem space and breaks it down into smaller entities that are easier to manage, showing how they relate to each other and how they're different from each other. So not only helps us with understanding, but it allows us to take one block at a time, understand one block at a time, and it just makes the whole concept more manageable. The components that we're going to have that make up the system are going to be identified. Those oftentimes there's a one-to-one relationship with a block that will show up on a reference model and a component, or the block might be abstracted to the point that there are many, many underlying components that make up the higher level building block. But in any case, there's a hierarchical representation that's at work. And by going through block by block, sort of like we alluded to with some of the earlier examples, forces us to think about, do we want to use this? Is this important to us? Or can we set this block aside because it really doesn't apply to our situation? And by doing that, it gives you a more systematic, more complete way of thinking through how you're going to solve the problem, making sure you don't ignore important things. And where you do decide to take one path versus another, or not use something and replace it with something different, gives you an opportunity to record that and document the reasoning and the trade-off determinations that were used. This is an example of the open group just leading to how building blocks can be used. The first chart here is more of not so much a reference model as it is a relationship of management frameworks. It is useful reference in terms of how you would have your management frameworks working together. So in the middle here, in the light blue area, we see what would typically be the enterprise architecture activity, developing EA definitions at the strategic level, sort of overarching the company or the enterprise. The segment level, which is one particular business area. Capabilities are specific solutions within those business areas. And then for each of those, there would be you would be making use of existing services and resources, and also adding new services and resources. Over in my solution development space, or my solution architecture space, there'd be various tools at work that would allow me to create, now because this is a cloud-focused reference model is what they call the, as you can see at the bottom, the cloud ecosystem reference model that the Open Group publishes. And you can Google that and read a lot of detail about this entire reference model. It's very complete. But since we're cloud focused, we're again looking at solutions that are either infrastructure related, platform related, or business software as a solution oriented. And then the linkage of our operations management activities of delivering, deploying the solution and managing it, whether it be new services or new applications. And along the bottom here, it says, in terms of creating these architectural definitions, there's a set of standard building blocks that we're going to agree on to represent all these capabilities. So if we go to the next chart, this is sort of an expansion of this idea. This is where you start getting into more what you consider a reference architecture, and this is the reference model. And what they're showing here, and this is more of an a la carte, sort of a shopping list type of thing. It sort of combines the idea that you have a model here showing who the actors are. If you recall back to the earlier example where we showed the cloud infrastructure, the cloud consumer, the cloud provider, and the types of things that they do. This takes it to another level and explains who does what they create. And to the extent that I have these cloud-based solution options, I have all these light green, bluish green oval shapes are how we represent service building blocks. So within the idea here is if you're going to establish a relationship with a cloud provider, these are all the types of services that you might want to consider establishing with them, or that you would expect them to offer in some way, shape, or form. And it gives you an opportunity to read, so behind the scenes, there are documents here that the Open Group has put together to describe in detail what these architecture building blocks represent in terms of what is the description of each of these services. Why is it? What's the value associated with it? Why is it necessary? And these are just considered to be the standard best practice items that would be available in any high quality cloud-based solution. So you can use this as a starting point to put your own version of this together. And by having this sort of shopping list approach, you can go through these one by one, educate yourself as to what they represent, and then ask yourself, will this or should this apply to our solution? And if so, we can keep it in and make sure that we get things put in place to address those concerns. So it's just another way of representing reference architecture as a way to provide guidance for putting cloud-based solutions together. And this is just showing how narrowly focused at the solution level a building block-oriented reference architecture can be. This particular one is Microsoft's lending message bus, which is really just showing how in mortgage lending there is a standard messaging scheme called MISMO, and it's useful for organizations that might have had all these different types of inputs, like maybe certain types of XML, maybe certain types of lending institutions are sending in files with their own unique format, like the Fannie Mae files. You used to have hard-coded processing to convert all these into internally useful things. What this reference model is all about is using a specific building block that's capable of transforming these various inputs and these variations in different types of formats into a single output standard that can then be used by anyone, because it's a defined standard that everybody's agreed to for this type of loan processing. So the building block definition of what the MISMO accelerator does is obviously a key aspect of this particular reference architecture. And this is just really trying to emphasize again, well, what's the difference between the reference architecture and the reference model? So the reference model is a part of the reference architecture, as we've discussed. The overall reference architecture includes the models and the patterns that it's based on, but it also includes all that other type of documentation that we talked about, the standards, the best practices, the guidelines, the policies, the principles. The reference model is there because it is the most commonly used, most easily digested, quick way to get up to speed, way to communicate what the reference architecture is all about at a high level. and it tends to show by the nature of what boxes are on the chart and what the names of those boxes are, it tends to establish the initial high-level taxonomy that the whole architecture is based on. There's some recommendations to sort of additional thoughts about how to make best use of reference architecture. And I sort of alluded to this first point earlier. You can think of it as a partially instantiated pattern where you've taken good pattern concepts and added some specialized detail to make them more relevant to the needs of your organization. In most cases, you'd like to know that what you're recommending in your reference architecture is proven, either internally, ideally, or by through prototyping experiments that you've done, or through expert industry consultation that you've sought out. Question, is it correct to say that the reference architecture meta model is applicable to a reference architecture adopted by an enterprise at the application platform space and technology space? Yeah, the meta model that we looked at, just zoom back to it here real quickly so we know what we're talking about. This diagram of all the different pieces, this is considered to be a generic meta model that in an ideal world, no matter what level you were at, whether you were at the enterprise architecture level or whether you were down at the technology level, if you think about it, all these different elements could apply and should apply ideally no matter what. So all that really changes is the scope. If it's an enterprise architecture reference model, obviously it's going to have a broader scope. The principles and the policies for enterprise architecture models are going to tend to be higher level principles, higher level policies that are meant to span across large portions of the business. Whereas if you were creating a reference architecture for like an application, IT services that are made available through an API to serve as an application platform, let's say, you would still have most of these same things would come into play. You'd still have terms to define, you'd still have best practices, you'd still have standards, you'd still have principles. They're just at a lower level of detail and they're focused on that particular type of domain. So I guess if I understood the question correctly, this is considered to be a generically a good, useful model for any type of reference architecture, regardless of the domain. Interoperability is always a common goal of most architecture activity. You want, especially in recent years, people are looking for ways to, increase the looseness of the coupling between applications and the systems that they run on, and decouple things in terms of messaging, and looking for a high degree of portability so that solutions can be ported between different operating systems, be designed with technologies that allow for that. So to the extent that your reference architecture is concerned about interoperability, there's a lot of things that can be built in that would help with that. Very important that you get very explicit about the types of interfaces that are used, the vision for how things are going to be upgraded, where you expect to have the ability to change out from one vendor to another vendor because things are sitting behind a carefully controlled standardized interface or API of some sort. And reference architectures oftentimes will help this by defining the qualities and the overall standards that would apply to all the components so that everybody has to design to a certain set of rules that will make that interoperability vision more achievable. I was just looking at that last question again. Just one other thing I would add is that a lot of times reference architectures come into existence in a lot of different ways, and it's like all aspects of architecture. There's the ideal definition of what everything should be and how complete it should be, and then there's the practical, the real world scenario of where you might inherit a reference architecture that doesn't have 50% of that documentation that we talked about. That doesn't mean you can't use it. It just means that over time, depending on, and this chart right here sort of goes to that, depending on the nature of your organization and depending on how important that particular reference architecture is going to be to you strategically going forward, that sort of dictates how much time and energy you're going to put into making it more complete and more usable and more enforceable to a broader group of people. So the point here is if I'm in a very small organization that uses low ceremony and a lot of things are done by tribal knowledge and you can get away with it because you have very small cohesive teams, you can get away with a lot less formal documentation in your reference architecture because a lot of people just, because they work in a small group, they can understand it. So if you're lucky enough to have that type of working environment, you don't necessarily need to invest that time and energy into all that formal documentation. But it doesn't take long as you move up the organization complexity curve that having that documentation is very important because you start dealing with different teams from different parts of the organization. They have different backgrounds. You also have to think about people coming in that are just new to the organization, new hires, people that transfer in, contract people that are brought in. What's the easy, what's it take to bring people up to speed so we're all on the same page? And that's where reference architecture documentation completeness can really help. Just as a follow-up question that just came in on the last one, is it a general practice that there is governance around the adopted reference architecture to be compliant with the reference architecture meta model? I would say that if you had a really good governance setup around enterprise architecture or solution architecture, you would want to enforce that to some degree. You could take that suggested diagram and sort of prune it and tailor a little bit to fit what you think is practical for your own needs. But that would be an excellent source of governance, because a lot of what governance does is define for the organization what they want to be reusable and what they want people to use as a starting point to ensure that there's the correct amount of integration and standardization across the enterprise. And the reference architecture is such an incredibly important element of achieving that a lot of times the architecture boards or the lead architects will have teams that are responsible for creating the reference architecture and then enforcing its, making sure it gets distributed to new project teams, making sure that it is part of what gets looked at when you conduct the compliance reviews. So as part of what it would take to approve a new reference architecture, to me, in my book, it would be very reasonable to have, a short document that explains here's the minimum content. And for starters, it could be a lot of what we call out in this presentation. But like I say, you tailor it to your needs, but having that minimal expectation of what any new reference architecture should have in it, I think would be a very reasonable and appropriate governance process, because there's a lot at stake and you want to get it right. So the summary here for reference architectures is to give us a foundation to build on. We want that foundation to be built on proven stuff as much as possible, best practices that we found to work, or best practices that we know have worked well in the industry that we've studied and tested enough to believe that we can move forward with. It might be solutions, it might be a foundation for the actual solution itself, or it might be a foundation that we have to integrate with. In either case, it's very important to both the solution and the overall organization to get that information across right up front in a well-documented fashion. It gets us to think about the higher level concerns, the primary concerns that are the most architecturally important to us, to think through those things, look for risks, look for things that are missing that we hadn't thought of before we get too far into the detailed design process. And it's just a good communication tool. One of the most powerful parts of reference architecture is that I use the term always enables the best foot forward approach, meaning that the last project that used the reference architecture puts they have a meeting at the end as part of their wrap up, like any methodology would call for, whether you're using RUP or some RUP variant or any other type of methodology. It's always good to have a lessons learned session at the end of the project to say, what did we learn? what aspect of the reference architecture did not work well for us and why, and or what did we come up with that really worked well that could be a solution for future teams that maybe should be considered to be added to the reference architecture, or maybe as a grounds for making some modifications to some part of the reference architecture so that we can do things even better going forward. So it's a living, breathing thing. You want every team to start with the latest and greatest best practice information, and you'd like every team at the end of the project to have the opportunity to make it even better. And that's true for a lot of things, not just reference architecture. That you could take that same philosophy and apply it to policies and standards and procedures as well. So that wraps up our formal presentation. I just want to quickly mention that WebAge does offer on a regular basis, at least once a month, you should find offerings for both of these classes. These are extended training classes, meaning that they're 4 days long. And we mention these because both of these go into great detail about how reference architectures are developed, how they fit into the EA and SA development cycles. And there's a lot more examples than what we had time to go through today. So if you have an interest in a deepening your understanding of architectural practice at either the enterprise or solution level, including what we discussed today, I'd certainly recommend looking into these courses. Just from a contact and follow-up standpoint, there's let me do my cut and paste that I promised. I should have done that a little bit earlier. I'm going to take a set of text here and blast it out to you in the chat box. So you should have seen that come through. You can just grab that entire string of text and plop it into your favorite text or Word document. And you'll have some links that include what you see here. I want to mention that at the bottom of the page here, there's a couple of real good reference articles. They're somewhat dated, so you don't want to pay too much attention to the technology discussion, but you can certainly look at the process and the basic philosophy they follow in these two pieces of reference material here. One's from the Developer Works area of IBM, which we know has got a lot of good stuff in it, but this particular one is specifically aimed at an in-depth discussion of how to make reference architecture work effectively. And this one is very good as well. It reflects a lot of real-world input from a team of people that got together and talked about what reference architecture is for them, why we do it, what we include, how we make it work. And they sort of distilled all that input from a wide variety of people that used reference architecture in a lot of different ways, and sort of congealed it into one set of what they consider best practice information. So I'd encourage you to go look at those references. Those are in that paste that I just gave you. Okay, well, that wraps it up for today. Sorry we ran a little bit long, but I appreciate you hanging in. And are there any more questions at this point that I could help anybody with? Don't see anything coming in, but so thank you very much for your attendance, and look forward to having you back for our future presentation. You should all be on the email distribution, so you'll automatically be notified for our next topic. I don't, off the top of my head, I haven't heard what the next topic is going to be yet. I don't know if that's been decided, but you should be expecting that there will be another webinar within the next 6 weeks or so, and you'll be getting an email within the next few weeks identifying that topic and giving you an opportunity to register for that. So thanks very much, and we look forward to seeing you in the future.